Okay, our next question is find the coordinates of E, one of the points of intersection between fx and gx. So at a point of intersection, here we have two at points A and points E, but at points of intersection, the two graphs are equal to each other. So the two functions, fx and gx, would be equal. Now, if we make them equal to each other, that will allow us to find the x coordinates of intersection. So fx is negative 4x squared minus 8x plus 60. And gx is equals to 4x plus 20. Now I have created an equation and I can solve x. So first, let's move everything to one side of the equation. So that will be 4x squared, and that will become plus 8x plus 4x, which is already on this side, minus 60 plus 20. And if I simplify that, it is 4x squared plus 12x minus 40. Now again, I can see that all of the coefficients are multiples of 4. So I would divide everywhere by 4. So 0 divided by 4 is 0. 4 divided by 4 is 1. 12 divided by 4 is 3. And 40 divided by 4 is 10. Alternatively, you can use the quadratic equation or the quadratic formula to solve x. But sometimes factorization is a bit faster. So I have two values of x, and then I have 5 and 2, so 2 times 5 gives me 10. And I want to create a positive value in the middle, so the bigger number, the 5, will get the positive value. Therefore, x would be equal to plus 2, or x will be equal to negative 5. Now for the coordinate of E, we can see that the x value is positive because it's on the right hand side of the y-axis. Also, we have already found the negative 5 before. So the coordinate of E, we would use x is equals to 2. Now in order to find the y value, I can substitute that 2 either into the quadratic equation or into the linear equation. And I recommend you guys use the linear equation because it's a bit simpler to work with. So y is equals to 4 times 2 plus 20, which is 28. Therefore, the coordinates of E is x is equals to 2, and the y coordinate is equals to 28. Our next question is pretty simple. It says, determine the length of PQ if PQ is parallel to the y-axis. Now let's first see what we have. The coordinates of P and Q we can find. P is the turning point of the parabola, and Q is on the same axis of symmetry. So the x coordinate of Q is x is also equals to negative 1 because it's on this line. And that's what it means by saying it's parallel to the y-axis. All that they are saying is that this line is running straight down or parallel. So they are saying this PQ is vertical. And now that I have the x value of Q, I can find the y value of Q. So Q is on the line GX, which is 4x plus 20. And the y value of Q is where x is equals to negative 1. So that is equals to 16. So Q's coordinates are -1 and 16. Now you could see the length of this line. There's no difference in the x's, but there's a difference in the y values. So the length of PQ is equals to 64 minus 16, which is equals to 48 units. Our next question says, if RT is equals to 120 units, determine the length of OS. So let's see where RT is. Here is R, and here we have T, and we can see that RT is a perpendicular line through the x-axis, so we know that this is a perfectly vertical line. So the coordinates of R and T share the same x values. And also we can see that R is higher than T, so the y value would be more for R than the y value of T. R is on the straight line and T is on the parabola. And this distance is given as 120 units. And what we want to find is OS. So actually what they are asking us to solve is the x coordinate, because if I can find the x coordinate of either R or T, then I would find the length of O to S, which is on the x-axis. So RT is equals to 120. But RT is the same as saying GX minus fx is equals to 120. The reason why I say gx first is because gx represents the straight line, and the y value at point R of the straight line is higher or more than the y value of t, which is on the parabola. So I want to subtract the smaller value or the lower value from the higher value. Therefore, I place the graph which is higher first. And now we simply substitute. So gx is 4x plus 20, and I subtract fx, which is negative 4x squared minus 8x plus 60. That difference is equals to 120 units. Notice that this is actually saying the difference of y values, because gx and fx represent y values. And now we're just translating it into those equations. Notice also when I subtract fx, I put it in brackets. This will allow me to fully subtract it, but also to see the sign change when I multiply out. So let's multiply out. It's 4x plus 20, negative 1 times negative 4, it's plus 4x squared, negative 1 times negative 8, it's plus 8x, and negative 1 times plus 60 is negative 60. That is equals to 120. Now we can simplify by adding up like terms. So it's 4x squared. 4x plus 8x is plus 12x. Plus 20 minus 60 is minus 40. And I bring this 120 over. So it's minus 120. It's equal to 0. Now again, I can divide everywhere by 4. And I can add these two together. So it's 4x squared plus 12x minus 160. Dividing everywhere by 4, because we have multiples of 4, I find that this is x squared plus 3x minus 40. So what you can do now is either use the quadratic formula or you can factorize. If you're comfortable with factorizing, it will be a bit faster than the quadratic formula. So the factors of 40 that will give me 3 is 8 and 5. 5 times 8 is equals to 40, and I'll make the 8 positive and the 5 negative. Now I would solve the x values, so x is equals to 5 or x is equals to negative 8. Now if you look on the graph, RT is on the right hand side of the y-axis, so we would use x is equals to 5. So the x value for R would be 5, the x value for t would be 5, and the x value for s would also be 5. And the question was, find the length of O to S. So therefore, the length of OS is equals to 5 units. And then our last question is, for which values of x is fx bigger than gx? Now what this means is, if fx is bigger than gx, then the y values of the parabola is higher than the y values of the straight line. And I can see that the y values of the parabola, which is f, is higher than the y values of the straight line in this area, from point A up until point E. So everything on the right of point E, the parabola, is lower than the straight line, and to the left of point A, the parabola is lower. But we're asking, where's the parabola, higher or above the straight line? And that's for the points from x is from x negative 5 up until x equals to 2, which is the coordinates of E, which we have calculated earlier. And our next question is, where is fx times gx smaller than 0? And this is where you need to remember simple multiplication rules. So a positive value times a positive value would give us a positive answer, which is bigger than 0. And a negative value times a negative value would give us a positive answer, which is also bigger than 0. But we're looking for smaller than 0. So that will be a positive times a negative value, which will give us a negative value, which is smaller than 0, or a negative times a positive value, which is also negative, which is smaller than 0. What it means in terms of our functions or our diagram is, everything above the x-axis is positive or bigger than 0, and everything below the x-axis would be regarded as smaller than 0 or negative. And we want to find the position where these two graphs is either positive and negative or negative and positive to produce a negative value when we multiply them out. So the best strategy for this is to use a ruler and go along the x-axis, because we want to identify points where the graph shifts from positive to negative. And the first point is here at coordinate A, and I draw a straight line through it. And I follow it, and I see the next point where the graph shift is at point B. So on the left of this first line which I've drawn in, I can see that the straight line is negative and the parabola would be negative. So a negative times a negative is a positive value, and that's not what we're looking for. Then in the next section, I can see that the parabola is positive, meaning above the x-axis, and the straight line is positive. And so for this section, the parabola times the straight line would be positive, but we're still looking for negative. And then after this line, which I've drawn in, I can see that the straight line is positive, but the parabola is negative. And that means it's a positive times a negative, which will produce a negative value, and therefore we have found our point. So this value of x here is 3, and everything from 3 more to the right, you can see that the straight line would stay positive and the parabola would stay negative. So x must be bigger than 3.